And as I stated before, TFTP is not a reliable connection. So what's going to happen is you're going to say, hey, TFTP server, give me this file. And he's going to say, here it comes. And he doesn't give a damn if you got it or not. He's just spitting it out. It's not like FTP where he's going to send a little bit of it and say, hey, did you get that? And you're like, yeah, I got it, thanks. And send a little bit more. Hey, did you get that? You know, I missed one piece of that. Could you retransmit? Not a problem, buddy. That's what I'm here for. That's what I'm running FTP. Let me send that back to you. UDP, it's like, here you go, motherfucker. You can take all this at once, or you can just go piss off. It doesn't matter to me because I'm just going to spit it out. I'm not going to make sure that you got it or not. And as I showed earlier, you do get like bangs, I mean exclamation marks, just like a ping. So if you got dots in there, you could probably tell that you dropped something, and you might want to either try this again or run this feature, the verify command. And I usually run this regardless of whether I think there's a problem or not. And what you do is you issue verify space, and then it's going to be MD5, and then the location that you stored the image in, and then the name, obviously. And what it's going to do is it's going to think about it. It's going to create an MD5 hash, and at the end it's going to give you this number. And you're going to compare this number to a known good MD5 hash. And let me jump ahead a slide here. So where you can get this from is when you download your Cisco iOS image. I love this. This web page will show you, and let me actually make this bigger here. It's going to give you this MD5 hash. So what you can do is you can keep this page open or just copy this, and this is what you want that MD5 verification to match. So in this case, with this image, I'm going to download it to my device, and then I'm going to run this the verify MD5 hash on it. And then if everything's golden, I should get this exact same hash. Now, I put an error asterisk here because we're going to go back to the prior slide, and I'm going to tell you why this always doesn't work. Well, I'm going to tell you that it doesn't always work. I'm not going to give you why, because honestly I'm not 100% sure. In this case though, it does match, and that's a great thing. We've gone out and we've verified that the MD5 hash matches, so we're reasonably assured, I mean as much as we can be, this file got from the TFTP server to our device all in one piece. And here comes the note. While this is a great feature, the MD5 hash does not always match, especially with older iOS images. I've run into this, and we'll see this in the lab portion, that the hash that we're generating for this exact same file does not match this. And I don't know exactly why this is. This actually was a live capture from the device we're going to be looking at. It's called R2, and we can see when I did this earlier, it did match that MD5. When we see it in the lab, it won't be. So I did do a minor change, and I think that might have thrown off either the way that the iOS reads the code or whatever variables it uses for the MD5 hash. Either way, we'll see that this isn't a deal breaker. Like I say here, if the image is running on a device in your network, so if you got it up on a device and it's running successfully, perform the verification on that file, that known good iOS file, and see what the MD5 hash is. And this is what we'll see in the lab portion. And you can use that to verify the image quote-unquote purity on your other devices. And I won't touch this a whole lot more, but all I want to tell you is that this does not match the MD5 hash on the Cisco web page. Go with the second method. Find, a device on your network where this is, where this iOS image is running successfully, and then perform the MD5 verification there and see if you get a different hash. If you do, you can use that hash to verify the code that you loaded to the new device, and this will make a lot more sense in the lab portion. And one other cool option with the verify command is that you can actually put in the expected MD5 hash. So in this case, we've got this straight off the website, and we're on R2, and we're verifying this image that's in Flash, and we go ahead and we specify at the end that we want it to compare it with this known good hash. So it runs through it, thinks about it, and it says verified, and it gives us that hash. Cool, this is good, it works. So I did the same thing here, except I changed the last 4 characters. So this is not a good hash, this is a bad hash, so we expect that it will not match this. And you can see it'll give you an error. It says, hey, this is what you submitted, this is what you expected, and this is what we came up with. So you can see that these don't match. So this is really good. A lot of times you're not going to need this because you can just run this command and eye it up. But if you want to be doubly sure, just go ahead and put this in there. It's kind of nice. So at the beginning of this lesson, I told you that TFTP was unreliable and didn't have the security that FTP has. So why would we use this? And the short answer is you wouldn't if it didn't give you some significant advantage. And this is a case where it might do this. So in this case, we've got our FTP server or Cisco Works up here, and R2 is a remote site. And here's our connection. It doesn't have to be the carrier call, but Let's just say that in this case this is a 256K connection, and well, I probably should have drawn this different, but these are full T1s. You know, more realistically, you're not going to have routers back here, you're going to have switches, and these will be Ethernet connections. Let's just put our imagination caps and pretend that this is switch 3 and switch 4, and it's connected to R2, which is our remote router via fast Ethernet. So in this case, we could go from switch 4 and we could say, hey, FTP server, send me an iOS image so that I can upgrade. And it says, sure, you know, and we've ever used an FTP and everything's going great, except that we're hitting this huge bottleneck here. It's really slow across here. 256K, and it's not that fast anymore. And this could be, you know, an ancient network where this is just a 56K, in which case, upgrade your fucking pipes. But I digress. In the real world, I have run into this, where I've got a grip of usually switches that are located at a remote site that I could use FTP or Cisco Works or some other method to get the image from point A to point B. But what's easier is, especially with the newer like the ISR routers, you can get a router with a big fat flash on here. It has 256 megabytes of flash. So what I can do is I can say, hey, FTP server, give me that switch image and let me store it in my flash here. So I take the one-time hit going across this slow pipe, getting it here. Now I turn R2 into a TFTP server, and maybe I ACL it off so that only stuff on LAN can get to it. And I've got, say, 10 switch stacks there. So now I can go from these 10 switch stacks at LAN speed, you know, fast Ethernet speed, 100 meg, and get that image. Zip, 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 10 different times. And I've significantly saved the amount of time it's going to take me to transfer that image from site A to each of these 10 switch stacks. You know, it would take 10 times as long, you know, minus the cost for the Ethernet speed, if you followed my brain math. Anyways, in situations like that, it significantly reduces the amount of time to get that file across. And also, once you get it here, you've got a valid image. You know, you can run your verification command, and because you're not going across this slow ass pipe, you're more likely to get a pure image across there, not to drop packets or anything like that. So in summary, TFTP is not the best option for transferring files, but it does come in handy in a couple of key situations, like the one I just showed you, where your server is very remote on the network, where you've got either an unreliable connection and or a slow connection between you and that FTP server. So if you're going to be putting that file out to multiple devices, and that'll happen a lot of times with switches, you'll have the same switches in a multiple stacks and you want to upgrade the code on all of them, but your Cisco Works or FTP server is way the hell away from that location. If you can get that file down to a local device on the LAN and then turn that device into a TFTP server, you can greatly speed up your time to share that code out to your devices, your end devices. Of course, you should always be aware of the security issues. What I would do is I would only use this temporarily and for a short time. Be sure that when you're done that you go in and you shut this off with the no TFTP server command. Furthermore, it's probably a good idea to ACL this off, even if you're going to use this for a short period of time so that only certain hosts can get to it. And especially in the situation like, say, with that last slide. Let me pop back up there real quick. Say that you have the necessity to pre-stage this. Say that, you know, it's Friday and you know that during the weekend the NOC is going to actually do the code upgrade. So you can pre-stage this by moving the code from your FTP server to R2 and then making R2 into a TFTP server. What you probably want to do then, because you don't know how long this is going to be open, is just go ahead and put an ACL on there and say, hey, I'm opening this up for TFTP, but I only want devices, you know, switch 1 through switch 10 to get this, and you can specify that here, or at the very least make sure that it's only stuff on the LAN that can get to it and nothing from the big bad internet. So that's going to be about it for the summary. Hopefully I'll see you on the lab portion of this. This is something that you're probably going to want to know for real world applications because it can come in handy. So I'll see you over on the lab.